I'm pretty sure you know Professor Tommaso Calarco. I personally started my quantum journey with him 2 years ago when I got into the topic, and he hosted the EQTC conference, the quantum flagship main conference. And he was the one in 2016 who authored the Quantum Manifesto, which provided the impetus for the European Commission to actually start Quantum Flagship, the big initiative and funding and promoting initiative. So, Tommaso Calarco is professor at the Institute of Physics and Astronomy, Augusto Righi in Bologna. He is, of course, in Jülich, the research center, and then also professor of theoretical physics at the University of Cologne. There he is also now, I see you, and Tommaso, it's great to have you. I see the Quantum Flagship background. You're all set, and stage is yours.
Thank you very much. Thanks a lot. Also for having mentioned that our EQTC conference, which is taking place next week, the Quantum Flagship biannual conference in Hanover next week. So I guess, and I hope that many of you will be participating there. So what I've been asked to talk about here is a little bit, our investment in infrastructure in quantum technologies, what is on now in Europe, and I will give a small preview about what is coming also. So we will see that in the coming slides. So, the starting point is, of course, the European Quantum Flagship, which, as was mentioned, started 5 years ago. And the idea is to start really from the scientific excellence that we have in Europe to translate it into industry and competitiveness for our continent, in order not only to be able to develop our own technology in an independent way without having to buy everything from outside of Europe, but also to attract investment, research, and business really to our continent. So this is actually working at the moment. In fact, you can see here, I am recycling a slide from the presentation I gave at the kickoff meeting of the flagship 5 years ago in Vienna. So these were the then starting projects in the 5 pillars, so in the 5 areas. And there are 4 application areas, as you know: communication, simulation, sensing, metrology, and computing, and also an underlying area of basic science. And I am copying this slide here because we had some very ambitious goals. And it's always a question, a very important question, whenever we talk about this field, as well as other fields of deep tech, that we are sort of trying to control hype, to manage expectations, to avoid completely, to promise something which will not happen. And of course, at the same time, it's a difficult task because we have to find a balance and also be ambitious. So these were the objectives that we set out 5 years ago, and I compare immediately them with the objectives that were reached. So this is a slide instead from our cluster review meeting held last year in Paris. And we see that, as a matter of fact, not only we have achieved almost all of those goals, but in some cases we went beyond. For instance, we have, I would like to highlight here, practical quantum advantage. So the Americans, the Google in particular, made an experiment, but also the Chinese Academy of Sciences made experiments on quantum, what they call quantum supremacy, in the sense of, quantum computing outperforming classical supercomputers on some problem. And the problems which were, and this was really an important breakthrough, a great achievement scientifically and in terms of engineering needed for that. It is, of course, an academic achievement because those were problems which do not bring a practical advantage in the sense of solving some problem which has other applications. In this case, we can say that in Europe, for the first time, and specifically in the field of quantum simulation, as you can see here, we had the solutions of two-dimensional Hamiltonian problems which are not achievable with supercomputers, and this has already been used to move the field forward. This is just one example of some aspects in which we have really gone beyond what we had been promising in the beginning. And if we think about investment in infrastructure, also something which was not obvious in the beginning of the flagship and that we now have is so many startups offering and commercializing quantum computers in essentially all the available platforms. And this, of course, has a very strong relevance to infrastructure. And I will come back to that, not only for computing, but also for communication in a moment. So here, we are moving from a flagship to what we familiarly could call a fleet in the sense that, the flagship initiative is really taking the fundamental research and turning into technology provision for the further developments. Of course, it relies on the aspects more of Horizon Europe, the research and innovation program of the European Union. For instance, in fundamental research, the European Research Council, Marie Curie actions, really where we nurture the development of that talent in Europe. But then it moves towards infrastructure, which is also in the title of today's talk, in the sense of, really bringing those technologies into fruition in infrastructure for quantum communication and for quantum computing. So we will discuss that in a moment, as well as, very important in the new program, Digital Europe, the program for advanced digital skills in terms of developing training courses, master programs, curricula for, training the next generation of engineers, and also upskilling and reskilling existing engineers into becoming quantum engineers, if you wish. And on the horizon, there is also the quantum fund in terms of really of investment, including, acquiring shares of companies to, promote our startups and scale-ups with a cooperation between the European Innovation Fund, European Innovation Council, and also the European Investment Bank towards a European quantum fund. So here is, in terms of all these lines of activity, this is a slide which I got from the European Commission about sort of the tentative timeline. And this is already wrong, if you wish, because it will not stop in 2030. So this is something which I will mention in my last slide. So stay tuned for that, and stay tuned for some important announcement which will come in the next future. But here we see that the flagship, so until the plan that was made until the end of this decade was to start, of course, with the ramp-up phase, which is now concluded, and now the technology demonstration phase of the flagship to move towards implementation. And this already fits into the deployment in Digital Europe in terms of already first pilot projects on quantum simulation, and also deployed at a European supercomputing center. In this particular case, it's one project, HPCQS, which is located then also in Jülich and also in Paris. So 2 quantum simulators are going to be deployed there, and 6 more are going to be deployed in supercomputing centers. We call them together the 6 + 1, the 7 sisters, in which all those different prototypes, according to different technologies, are going to be deployed at supercomputing centers. We will have one more slide in a moment about the general vision for that infrastructure. At the same time, the European quantum communication infrastructure, taking the prototypes and also commercial products which are available from increasing numbers of European startups, is taking this towards deployment, really, of that infrastructure. At the same time, we also started with pilot lines, projects in Horizon Europe, and this is going to be developed further in terms of the CHIPS Act. And, this has not yet started actually operationally, but this Quantum Technology Fund is going to be available very soon. Now, in terms of those infrastructures that I mentioned before, the quantum computing and simulation infrastructure, as I said, it's about bringing all these different platforms and, for the moment, co-locating them with supercomputing centers, but in the future also, creating a broader cloud-accessible infrastructure in order, on one end, to have a test bed for those who develop hardware, and making this hardware available to users to really check, what are the needs and how does it actually work. And in the meantime, in parallel, develop a database, a broad range of applications, not only for verification and validation of those machines, but also for new algorithms and use cases which can be useful for industry. And on the communication side, here it's about sort of enhancing the existing infrastructure, both in terms of terrestrial and of satellite components, to enhance this with quantum key distribution links, and in the future also to go towards really a quantum internet in terms of quantum repeaters and so on. So we start with what we have, integrating that quantum cryptography into the communication systems that we have for the moment at national level. Then it will be connected between member states for a series of applications, synchronization, protection of data, and so on, and then in the perspective to be a backbone for future quantum internet. So now here is a demonstration that we gave at the G20 now 2 years ago, in which for the first time between 3 member states of the European Union, of course that was made easier by the fact that the G20 was taking place in Trieste, so Slovenia and Croatia were not too far, so we could reach them with optical fibers. And here you see with, technological sovereignty even, because this was the G20 hosted by Italy. So we had an Italian startup, demonstrating and showcasing their devices for a video conference, which took place within these 3 member states of the European Union. And, more recently, we had sort of a more sophisticated demonstration. It's really online, the link to that, a demonstration with the heterogeneous links. So a tripartite link, but with 2 different startups participating into that with different technologies, continuous variables and discrete variable quantum key distribution, which work together in a network. At the same time, in the Digital Assembly, an event of the Swedish presidency in Stockholm 2 months ago, we have also demonstrated not only quantum communication, but also for the first time publicly demonstrated cloud access to a quantum computer. In this case, it was in Sweden. So we took a Swedish quantum computer in Göteborg, which was working, showcasing a simple machine learning task, which was, launched and demonstrated live, and also on sensing the aspect of quantum gravimetry with a gravimeter on stage measuring the gravitational field with unmatched accuracy there. And this is the same model of gravimetry from a French company, which actually acquired a startup which had been founded by Nobel laureate Alain Aspect. Actually was participating online also to that event, really to once again underscore the deep connection between fundamental research and entrepreneurship. And this kind of device is already deployed on Mount Etna in Italy for monitoring of volcanic activity. And in the future, there are ideas to extend this to a network of such gravimeters. This of course requires industrialization in the sense that the European quantum industry starts being stronger and stronger. This is an updated snapshot of our quantum industry consortium, which now reached 182 members from 23 countries, with a large proportion of SMEs, but also large enterprises, and a smaller portion of academics and RTOs. And this is, of course, the one official voice of all the European industry to not only do business to business interactions, but also to create the strategy for the future. And in particular, one important aspect which is very current now is the CHIPS Act, which was signed into law last week by the European Parliament with a final vote, and it contains an article on quantum chips, which I had the privilege to be able to suggest and push forward through the agenda there. And the point here is that quantum chips is not just your standard semiconductor chips, but it is very different kinds of chips which are necessary for all the different sorts of quantum processors, including ions, atoms, superconductors, semiconductors, color centers, photons, many different platforms. And in the CHIPS Act, the different lines of activities, the infrastructure which has been developed to enable that involves 3 lines: design libraries to really be able to have the IP, the know-how, how to make these things, and pilot lines to start producing them, also accessible to our startups in order to lower the threshold, the barrier for entry into the market, and also, of course, testing and experimentation facilities in order to enable validation of those products and really closing the whole innovation loop. So all of this is contained in our strategic research and industry agenda, which is being consulted with the whole community at the moment. And now the consultation is essentially closed. There will be some final feedback from the governing bodies of the flagship. And finally, we will hand it to the European Commission, which will use it to lay down the template for the different calls, which they are going to announce also in the next future, both in Horizon Europe and for the infrastructures that we discussed. And very importantly, the Quantum Industry Consortium, QUIC, has been giving a very strong input into this. And so this is really from the strategic research agenda, which was in the past, now the strategic research and industry agenda. And now on the international side, of course, this enables us to be really on par with the international competition, across the globe, which is investing a lot. So current estimates, this is a slide which has been presented at the Strategic Advisory Board meeting last time by the Coordination Action QCATS. I think the Chinese number, in the meantime, there is actually an in-depth analysis from the New Yorker, which shows that the Chinese number is not so big as the one which is quoted here. And I'm saying this because essentially it shows that Europe is in the end now the largest public investor in this field, which is going to position us with the whole ecosystem, which we see here, the quantum flagship at the core, the infrastructures, quantum computing and quantum communication, coming out of that, but involvement of member states with the funding agencies and also national programs, very important one, together with a quantum fund to support entrepreneurship, and of course, feeding all of this into the industrial development. So very much in line also with the spirit of the quantum effects event that we are seeing these 2 days in Stuttgart. And here is my last teaser in my last 30 seconds. Commissioner Breton, I cannot tell, of course, more because it will be for Commissioner Breton to announce, but here you see what he said on LinkedIn, a few weeks ago. So we expect that very soon in this fall, so before the end of the year, there will be a big announcement from the European Commission and member states about a future strategy for quantum technology, which will go even beyond what we already have planned, so beyond this decade, but for a next decade of important initiative at European level. So I guess that my time is up, so I will unshare the screen, and thank you very much for your attention.
And if you stay with us, I'll just have a look if there's maybe one question. We can take one question, and then we have to jump to the next panel if there is something. I think, Tommaso, you made it very clear. I wish you all a very good conference. EQTC is coming up. You said that already in Hanover. So all the luck there, and thank you for being with us today.
Thank you very much. Have a good conference. Bye.